Hey, welcome back. It's me, Mrs. Teets. Here we are in lesson 11.5, multi-stage probabilities. So this is going to come back a little bit later, but given that the probability that event B occurred given event A has occurred, remember the formula? So B given A is equal to the probability of A and B over the probability of A. So if we cross multiply this, we're going to be able to come up with different types of formulas. So I need to grab my pen. Hold on a second. Here we go. So in other words, if we put this over 1 and we cross multiply, I can tell you that the probability of A and B, and let's use the form A and B, is equal to the probability of B given A times the probability of A. So we're going to talk about this a little bit later. So I just wanted to start off with that. All right, it's just manipulating a formula we already know and we've already used. So we're not there yet, so let's look at a couple of multi-stage experiments. So right on to exercise 1. Consider the spinner shown below. The spinner has spun twice and the result is recorded. Are the outcomes of these two spins dependent or independent? Well, there's nobody taking a number off of the spinner or anything like that. So these two events are independent. So these two events are independent let's put a because in here. Because the first spin does not affect what happens in the second spin. Always explaining yourself is a good thing. So B, what is the probability that you will get an even on the first spin and a number greater than 5 on the second spin? So what we're looking for is the probability of an even and probability of a number greater than 5. So whenever we see the word and, that's going to translate to a times. So the probability of getting an even is 2, 4, 6, 8, so 4 out of 8. The and gives me a times. Now again, instead of using this and, we could use this and, kind of means the same thing. So 4 out of 8, and how many numbers are greater than 5? 6, 7, and 8. So 3 out of 8. Multiply them and we get 12 out of 64. You can leave it like that, or you can make it 3 out of 16, or you can represent it as a decimal. Remember, probability is one of the places in mathematics where reducing isn't always necessary. On to letter C. What is the probability that you will spin a prime number and a perfect square in either order? Notice that this is going to be a little bit more complicated than the first one because the either order really makes a difference. So what we're looking here is we're looking for the probability of a prime and a perfect square, or the probability of a perfect square and a prime, because order does matter in this case. So a prime and a perfect square. Let's see. A prime would be, go back up a little bit so I can see this. A prime would be I'm confused. Hold on one second. Oh, okay. I know. I'm looking at my notes and not making sense of this. So how many of these are perfect squares and primes? I guess that's the number I'm looking for. So prime and perfect square. Well, I have 1 out of 8 here. Okay, so I'm a little fried. Here we go. So let's do this by hand instead of trying to do it in my head, because that's a scary place sometimes. So the probability of prime and a perfect square. So how many primes are there? There's 4 out of 8. How many perfect squares are there? There's 2 out of 8. So this turns out 8 over 64, which is 1 over 8. That's where the 1 over 8 came from in my head. Or means a plus sign. So plus the same thing. Now the probability of the perfect square doesn't really change here. It's 2 out of 8 times the prime, 4 out of 8. So this also is going to be 8 over 64, which is 1/8. The or means you add them, so you get 2 over 8 or 1/4. Sorry for the delay there. So now we have to consider with replacement, without replacement. So you can tell, like with replacement, our denominators aren't going to change, but without replacement, and you take them and put them aside, our denominators are going to decrease by 1. So let's take a look at exercise 3 and see what I'm talking about. So a class consists of 12 girls and 8 boys. So 12 girls, 8 boys. A group of 3 is picked to give a speech. If the students are picked at random, what is the probability that they all will be boys? So we're talking about the probability of a boy, and then we have E's over there, and the probability of a boy, and the probability of a boy. So this is going to be, how many boys do we have? We have 8 boys out of 20. But the same boy can't give the same speech. So now we only have 7 boys, but we only have 19 to choose from. And for the last boy, we have 6 boys left out of 18 in the class. So this is going to turn out to be 14, I'll do the math for you, over 285, which is approximately 0.05. So the multiplication property of probability is crucial in many applications in engineering decision making. So exercise 4. Say that a power generating facility has 3 primary safety switches in case of an emergency. The probability that any one of these switches could fail is 5%. Remember, we think mathematically, we think as a number 0.05. So what is the probability all 3 will fail given the switches are independent of one another? So basically, what's that saying is that we want to know the probability of a failure or a fail switch and a fail switch and a fail switch. So what is that going to be? It's going to be 0.05 times 0.05 times 0.05, which is 0.000125. Or as a percent, remember it can still be percent too, it can be 0.0125. Looks a little better that, but make sure you follow it with that percent sign. So many times when using the multiplication rule, we need to be careful about how we frame the question. But if we properly frame it in terms of and or logical connectors, then the rules of probability will work out. So let's take a look at exercise 5, which is our last exercise of the lesson. A company was determining the effectiveness of its warranty sales on computers. They took data on the number of customers who purchased warranties on 2 different brands of computers. We'll call them type 1 and type 2. If a customer was chosen at random, what is the probability they did not choose a warranty? So what do we need to know? So there's two different computers here. So we need to know that what is the probability of buying the type 1 computer and no warranty, or, oops, I need a P there, probability of buying the type 2 and no warranty. So sometimes when we just take it and just put it into words and translate it, all of a sudden it becomes a little clearer. So the type 1 and no warranty. Now this is where we're going to be using our information, because remember, this is the probability of the type, I'm sorry, this is no warranty given type 1 computer. This is, I shouldn't say, yeah, this is the probability of no warranty given type 2 computer. So this is where this is coming from, that formula up at the top I was talking about. Okay, so I put a little reminder down here of what we talked about at the beginning of class, that the probability of A and B is the probability of B given A times the probability of A. And up here at the top, we have the probability of no warranty. I'm sorry, this is warranty. I wrote this incorrectly. This should be warranty. It should be the probability of warranty given computer 1 and the probability of warranty given computer 2. Because this says no warranty, so we need some new numbers here. So the other new number we need is the probability with no warranty. So 0.35 bought the warranty, 0.65 did not. And if 0.56 bought the warranty, 0.44 did not. All right, so over here on the left side, I wrote down, I just used what I have written down here. So the probability of type 1 and no warranty. Now I have to use the warranty first because that's what I'm given in my data, right? So I can't use the computer first. So I use no warranty given computer 1 times the probability of a warranty. So the probability of no warranty on computer 1 is 0.65 times the probability of picking type 1 computer is 0.68, plus the probability of no warranty given computer 2 is 0.44 times the probability of picking computer 2, which is 0.32. Put that whole thing into your calculator and you get 0.5828. Now I'm thinking that we might have to go over this again in class, and that's okay because it is a little bit confusing. So keeping that in mind, write it down, and when we open up our class lesson, say, go over exercise number 5, and maybe we'll be able to pull it apart a little bit easier, okay? A little bit further anyway. Usually, by the way, 0.58 would be our answer because it's usually to the nearest hundredth that we round to. Okay? Alrighty. Quick video, 14 minutes. As I always tell you, always make good choices and be kind to one another. See you next time.